Hello students, welcome to my YouTube channel. This is class 9 of lesson AC currents. Hope whatever the concepts have discussed in the previous sessions, all of you are understood. If not, watch the video repeatedly. And I hope you have collected the study materials and refer those things parallelly. Still you find any doubts, please update me through WhatsApp. So, in the current session, which is class number 9, I will discuss with mainly what is the meaning of Wattless current and followed by what is a tank circuit, which is generally called LC oscillator circuit. Both I will discuss one followed by the other. So, in order to discuss what is Wattless current, let us recall the concepts of the power which was discussed in the class 8. I have discussed about two powers there. One is true power one, the second is apparent power. So apparent power and true power. So let us recall the formulas once again. First of all, this lesson AC currents. So first of all, recall the formula for the power. Power is the product of IRMS and VRMS. So here whatever the current or whatever the voltage you will deal with only RMS. That you are having clarity. The reason to measure the AC currents, since its value is not constant anywhere, to measure the strength of the AC current or AC voltage, you require two things mainly. At the beginning of the sessions I discussed. One is RMS, the second is average. In average, since it is taken only for the half of the cycle, we cannot take into account. And RMS will be taken over the full cycle, hence that only will be taken in calculation of anything. So here for calculating power also I took power as product of VRMS and IRMS. And this product of this VRMS IRMS gives a power known as apparent power. What does it mean? This is the power actually supplied through the circuits. So for example, our household purpose will take a voltage about close to 220 volts. Somewhere the range is between 220 to 240 also. So usually 220 is the actual voltage required. Somewhere close to 230 also can take. And so let's say current some 10 ampere here already. Then 220 volts into 10 ampere RMS current gives 2200 watts. 2200 watts. Now what does it mean? That is a power known as apparent power you are supplying for the given house. So in that you can find so many electrical appliances. Based on the appliance category, some appliances may require more current, some appliances may require less current. So I will take two examples. One is electric heater, known as a geyser. The second is electric fan. So fan and electric geyser both will operate with the same voltage, but where the power will differ, the actual power consumes, known as true power, that is given by PT. This true power will vary according to the current, how much it takes, because your separate power in that fan will consume less current. The reason voltage being same, to get the less power or to consume the less power, current must be less. So for example, let's take a TV, LED TV takes about 110 watts. You can find the power ratings at the behind of the TV, where the power card goes inside. There you can find one technical label mentioning how much power it consumes. So according to that, assume a TV takes 220 volts, and as you know its power consumption, the true power is 110 watts. Then defaultly the current must be 0.5 ampere, because 110 into 0.5. 220 volts into 0.5 will give 110 watts. Take an example of geyser. Think the geyser consumes 2000 watts. Since the voltage is 220 volts, then close to 2000 watts means current must be somewhere around 9 to 10 ampere. So from this calculations you understood one thing: how much power you give to supply for a given house, the total power will be delivered to the house, and among the electrical appliances, the consumption of the power will vary according to the electrical appliance. Not only current, there is one more factor also will makes vary the consumption of the power, that is given by, see, VRMS, IRMS, cos phi. So this topic I discussed in the last session. So true power consumed, apparent power is supplied. This true power consumed will depend upon how much current is flowing through concerned electrical appliance, and moreover cos phi, which is an important thing known as power factor, also decides how much power the electrical appliance should consume. Now, from this VRMS, IRMS can be replaced as here as apparent power. So this formula can be modified as PT is equal to PA into cos phi. Now from this cos phi can be written as PT divided by PA. So what is power factor here? Which is a dimensionless quantity. How to define it? It's a ratio between true power to that of the apparent power. So make sure, if cos phi is 1, so what does it mean? Here power consumed must be equal to power supplied. So it happens only in the case of resistors. Why? So try to understand. I'll explain the concept in two different categories. Resistors are called as passive elements, even inductors, capacitors also, since any electrical circuit will be made up of three things: R, L, C. These are the passive elements, means they will consume the power. Now among R syllables include only with these three, so I deal with only R, L, C separately. So let us take in the case of resistor. Recall the derivation of relation between AC voltage and AC current, where in the case of pure resistor, I have given the derivation and finally given one conclusion that there is no phase angle, or you can say the phase angle between the AC voltage and AC current is 0 degree. Now substitute the phase angle here. What is cos 0? 1. If cos 0 becomes 1, what does it mean? True power is equal to apparent power, means resistive circuits will consume maximum power, or resistive circuits will consume the total power, how much you supply. I mean, how much apparent power it gives, that much will be the true power. That's the reason why, where and all you can find electrical appliances having resistive elements. For example, let's take electric geyser, electric iron box, electric toaster, or ordinary incandescent bulb. These elements, appliances, if you see, major thing as a work function is a resistor, a coil, a heating element. A heating element is nothing but a resistor. So such things, they will consume more power. So also one idea you can develop: electrical appliances which are majorly incorporated with resistive type are able to consume power in a maximum quantity. So that is the first conclusion you get. So here I write, in case of resistor circuits, phase angle is being 0, then cos phi will becomes 1. That meaning is true power is equal to apparent power. So this is the first conclusion. Second, I will come to the concept known as Wattless current. You take either in the case of capacitor or inductor, the phase angle is 90 degree. How? Just recall, in the case of pure inductor, current lags voltage. In case of capacitor, current leads the voltage. So you can take the statement either of the way. Here voltage leads the current or current lags the voltage. Both are same. Here current leads the voltage or voltage lags the current. By what angle? 90 degree. So in inductor, voltage leads, in capacitor, current leads. By what angles? 90 degree. Now substitute the same thing. What is cos 90? 0. Again here cos 90, 0. Now what does it mean? True power is equal to 0. Here also true power is equal to 0. Now just to make a small notice here. In case of pure inductor or pure capacitor, true power is 0. Now what does it mean? These current elements will never consume any power, since the phase angle between the current and voltage is 0. Then in such circuits where the power consumption becomes 0, then at that time what is the current flowing through those current elements is known as Wattless current. So very most important definition, Wattless current. The current through capacitor or inductor where power consumption is 0, or you can say the current through electric circuits where the power consumption is 0 is known as Wattless current. Make sure if the circuit is purely designed with inductor or capacitors or both, then only the Wattless current situation exists. Somewhere in the circuit, if you place any resistor, the current cannot be called as Wattless current. So this is the most important definition of mentioned the material. Please make it highlight and start reading the statement repeatedly. Important in 1 month category. So what is Wattless current? Hope you understood. Now I will ask one question. Compared to the ordinary incandescent bulb, wattage bulb, we will get in the market for ₹10. Compared to that, a tube light will consume less power. So less than that consumption power is CFL. Later CFL will have been overcome with LEDs, because present generation is going on. Now let us recall only about two things in this case. One is ordinary incandescent bulb, the second is tube light. What's the difference between these two? Tube light will give us more luminosity than incandescent bulb, but compared to the size, tube light is bigger, incandescent bulb is smaller. Even though if you see, power consumption, which is known as a true power, is less as in the case of tube light than that of ordinary wattage bulb. Why? Just recall, ordinary wattage bulb is purely resistor type. If you see in case of a tube light is a combination of RLC. How? The bulb contains filaments, that is resistor, and at the middle of the tube light you can find a small box-like structure which is known as choke. A choke is made up of inductor, and you can find a cylindrical structure right side, small one, known as starter coil, the name, but actually it's a capacitor. Since R, L, C are introduced, there must be some phase angle here, defaultly, because I said in case of resistors phase angle 90, in case of inductors, resistor 0, inductors 90, capacitors 90. When you combine all three, you will get a situation either inductor dominated or capacitor dominated. I am telling a situation apart resonance. Resonance situation, you leave it. Either of the case you take, before resonance or after resonance, you will get two things. One, either capacitor dominated or inductor dominated. If it is capacitor dominated, current leads voltage. If it is inductor dominated, voltage leads the current, but not by angle 90 degree. It is between 0 to 90. I discussed during LCR series circuit. Since the phase angle neither 0 nor 90 here, you will never get pure resistor or pure inductor. You will get a mix. Since the phase angle varies from 0 to 90, assume somewhere about 45 degree. Think a small example. Cos values will decrease as you go from 0 to 90. Cos 0 is 1, cos 90 is 0. So as the phase angle increases, true power consumed also decreases. Okay, understood. So small clarity in tube light, if you take the true power, The angle is neither 0 nor 90 since it's a combination of RLC. Hence, cos values decreases with increase in the angle. Then the true power will get less when you compare to the ordinary Wattage bulb. What is the ordinary Wattage bulb? This value is 1 because it's purely resistor. Then true power is equal to apparent power. That is how you can understand why a tube light will consume less power. So this is the most important concept related to the powers. So here what is the meaning of Wattless current here understood. And when the power becomes 0, the current to a circuit is known as Wattless current, which is most important definition. So try to get the information. I will give a small task. How much power will be consumed in the case of a combination of resistor versus inductor and resistor versus capacitor circuits, and LC circuit now I discuss. So this is a concept related to the what known as power. So after power, you will get a concept known as LC oscillatory circuit. So this is electric oscillator circuit, LC oscillator. See, these two things are out of syllabus, but it will come from the objective side. The formats are discussed in the respective sessions. Now, what is the new concept here called as LC oscillator circuit? So far we discussed about pure resistor, pure inductor, pure capacitor. What is the meaning of this LC oscillatory? See here, either inductor or capacitor if you take, the power consumption by those elements is 0. Then, if you take such two elements, join in series and give some electric power supply to that, for either for the capacitor or for the inductor. Since power consumption is not done, power will start distributing from capacitor to inductor, inductor to capacitor. So, the power will move in the form of currents in to and fro manner. It will not settle anywhere because of the energy density variations. So, such cases if you see, current will be moving in a to and fro manner, then they produce an oscillations in terms of electric currents. That's the reason why they're called as LC oscillatory circuits. What's the meaning of oscillations? To and fro. So, a small take an example. Take two persons, they never make any expenditure. One person is inductor, the other person is capacitor. If you give amount with, let's say inductor will transfer the amount to capacitor. Further, capacitor will transfer the amount to the inductor. Since nobody are interested in expenditure. Expenditure is you can compare as true power. What you given you compare it as apparent power. So here, apparent power will be same, true power will be equal to 0. So the apparent power will move from to and fro. So for that, let us start constructing a circuit. So I will start with a very, what you can say, easiest diagram. You can find some more diagrams in material, both are same, no need to get worried. See? This is a simple LC oscillatory circuit. So in the material, I have introduced a key K2 here and one extra battery along with K1 I have given. So that is removed here. So to understand this LC oscillator circuit, you require two expressions. From electrostatics, you know, energy stored across the capacitor is given in the formula half CV square. That is known as electrostatic energy stored in a capacitor when capacitor is fully charged. And from electromagnetic induction, energy stored across the inductor is given by half Li square. Even this expression I have discussed in person. So here this is electrostatics and this is magnetic. So symbols may vary but meaning is same. Here you can introduce capital E, here you can introduce capital B. Because it's a magnetic energy, this is electrical energy. For understanding purpose, I mentioned capacitor and inductor. You can replace the symbols with E and B. Now, let us understand how this oscillator circuit works. So, initially, take some external circuit. Assume one key is available here. So, here one key is there, which is open. Initial key is open. Using some extra of battery, you start charge the capacitor first. Okay, you charge the capacitor until it gets fully charged. So assume now capacitor is fully charged. So obviously one side it acquires positive, the other side it acquires negative. Now capacitor is fully charged. Now the energy stored is given as half CV square. Now you start close the K, which is in the circuit. Once key is closed, since here the electrostatic energy is more, capacitor will start discharge through inductor. So very simple mechanism, no need to get disturbed. So capacitor will start allow some current to flow through inductor. As the capacitor starts discharge, electrostatic energy will decrease and this will start produces magnetic flux. So mentioned in the diagram, it will start produces the magnetic flux across the inductor. You know, the change in the flux induces an EMF, acts in the opposite direction. That is given from the Lenz law, even EMI. I hope you have understood the concept. So when capacitors start discharging the energy in the form of current, the current will start producing a magnetic flux until the complete capacitor gets discharged. So when capacitor is fully discharged, here charges get vanish and the total electric energy what is available across the capacitor will store in the form of magnetic energy. Means this energy converts into magnetic energy across the inductor. So this is a first step. Now once the inductor get completely energized and capacitor is completely got discharged and this energy start start leakage. In the sense, this energy will start again in the form of it will start moving and it will start charging the capacitor. But as the magnetic flux varies across an inductor, it produces an induced EMF, and that induced EMF causes a current in opposite direction. Hence, if the energy start moving this way, an induced current will start move in this way. So make sure this is the direction where the magnetic energy flows. Because of changing the magnetic flux linked with the coil, it will charge the capacitor in opposite direction. See here you can find one thing. Last time upper plate was positive charged. After one cycle, down plate will get positive charge. Hope you understood. So initially the positive plate became negative, and initially the plate which was negative was became positive. After what time? After one complete discharge of the capacitor and one complete making zero energy of the inductor. Now this process repeats. Now here the complete magnetic flux is zero. Hope you understood now. So now if you erase all these things, you will get one conclusion that initially there was a electrostatic energy, that energy got converted into magnetic energy, further magnetic energy converted into electric energy. So in this whole process, energy never got wasted. The reason the power consumption is zero. But only one thing you can observe, that polarity of the plates got reversed. Now this process repeats in opposite direction. Since this down plate now is at high potential. Earlier the upper plate was at high potential. Now the down plate is being at high potential. Current again flows in opposite direction. This way. Until the inductor gets completely energized. Once inductor is fully energized, Here the charges will get vanish. Now the electrostatic energy became what? Magnetic energy. This magnetic energy will try to flow in this opposite direction, but the induced EMF will move in this direction. So here capacitor plates will get charged. By that time, energy across the inductor becomes zero. Here one thing you are supposed to understand. Initially the current was going in clock direction from capacitor to inductor. In the same direction, induced current from the inductor will move. So that's the reason why capacitor plates will get opposite polarity after one complete cycle. Now, earlier this was positive, now this was positive. So current will move this way. So if you observe, this is one complete anti-clock rotation. In one anti-clock rotation, I am telling about the beginning. In one anti-clock rotation, capacitor was positive initially, this plate, and loses the energy. Inductor got energy. Further, capacitor got energy. In next clock rotation, capacitor is got discharged. Inductor is got energized. Further, capacitor is got charged. So here I will give one small notations. In the step number 1, this is capacitor plates. This is positive, this was negative. So current was moving in anti-clock direction. So in a simple way, let's say, energy across the capacitor was not equal to 0. Energy across the inductor is 0 for 1 quarter rotation. So from here to here, assume the time taken is T/4. In the second step, capacitor energy becomes 0, means when inductor is fully energized. Inductor energy is not equal to 0, current goes in the same direction. This will take about T/4. So this is complete one cycle. I mean, capacitor to inductor fully energy got transferred. Understood? Now, here this energy again will flow to capacitor and inductor becomes 0. This current will go in opposite. And again last step, capacitor 0, inductor is not equal to 0, T/4. See here I mentioned the after process begins, or you can start this way. This is 0 and this is not equal to 0 for 1 quarter cycle. Again this will be not equal to 0 and this will be 0. Either of the process will be same. Again this is equal to 0 and this is not equal to 0. Again this is not equal to 0, this will be 0. Both gives the same meaning. So if you observe here, in the first quarter cycle, energy loses by the capacitor, it stores across the inductor, that is the meaning. In the next quarter cycle, inductor loses energy, that stores the energy across the capacitor. So by the time one anti-clock will complete. In next, the capacitor loses its energy, stores the inductor. In the next quarter cycle, by the time it was clock. In next quarter cycle, whatever the energy across the inductor will appear across the capacitor. This is not the final situation. So here, capacitor upper plate was positive at this moment. But here if you see, where? Here capacitor down plate will become positive. So T/4 plus T/4, T/2 means for half of the time period, the polarity of the plates get reversed. Now, on what frequency these plates will get reversed? That is given by F is equal to 1 divided by 2 pi root of LC. Based on this frequency only, the LC oscillator circuit works. Now, at any time if we take the total energy across the circuit is equal to energy across the inductor plus energy across the capacitor. You can substitute those expressions there as half LA square plus half CV square. Now, these oscillations will be used in working function of the amplifiers. So that we will discuss in semiconductors, where LC oscillator circuit is used in amplifying signals. So this is of the concept of LC oscillator circuit. But if you see frankly, the oscillations must be sustained. What's the meaning of sustained? See, actual oscillations, if we go, this is known as sustained oscillations. But if you take a true LC oscillator circuit, the oscillations are damped. The reason is why? Reason, energy somewhere is getting dissipated, means energy somewhere is consuming. If power is not consuming, energy is not consuming. Since you have taken LNC, as per the statements, there must be no energy loss or there must be no power loss. But even though, instead of these oscillations, you will get these oscillations in LNC circuit. Why? The reason is why? Here the inductor is made up of a wire. I told at the beginning, you can able to create a pure resistor, but it's difficult to create pure inductor, because without wired elements there is no inductor. Since it has certain length, a slight resistance will be there as hidden in the inductor. That resistance will start consuming certain amount of power. Because of that, the oscillations which are produced due to LC oscillator circuit are damped. Hope you have understood about these concepts. In the next session, I will discuss about transformers. Thank you.